Hassler here. I'm going to give you notes on 11.5. We're going to be talking about geometric sequences. And believe it or not, we've actually already talked about geometric sequences when we did exponential functions. And so just like we had stated before, a sequence is a list of numbers, but specifically a geometric sequence is a list of numbers that have a common ratio. Now, we said that arithmetic sequences have a common difference, but geometric sequences have a common ratio. And so when we talk about a common ratio, we are talking about a number that you multiply by to produce the numbers in the list. So that's why this is like exponential functions. With exponential functions, we multiplied by some number, either doubling it, so we multiplied by 2, or tripling, so we multiplied by 3, in order to create values in the table. The same thing can be said for geometric sequences. And so let's do some examples and some non-examples. So some examples of a geometric sequence would be something like 2, 4, 8, 16, ... And in order to create this sequence, I had to multiply by 2 to get each number in my list. And so we say that the common ratio, or R, would be 2. So for arithmetic, it was D for common difference. And for geometric, it is R for common ratio. All right, another example might be something like 60, 30, 10, ... And so now I got to think about, what would I multiply by? I know that we could say that I'm dividing by 2. Dividing by, oh man. All right, sorry, I have to erase this. This would actually be a non-example, wouldn't it? And so let me change this number real quick, right there. All right, let's try this again. So if I had the numbers 60, 30, 15, then again, I'm going to be, I know it feels like we're going to be dividing by 2 and dividing by 2, but a common ratio is written as what I multiply by. And so dividing by 2 is actually the same as multiplying by half. Multiplying by half. So dividing by 2 and multiplying by half represent the same thing, right? I could say, what is half of 60? 30. What is half of 30? 15. All right, so some non-examples would be something like 4, or 7, 10, 13. And why would this be something that is not geometric? Well, because I'm adding 3. And so if I'm adding 3, we said that this was arithmetic. Okay. Or if I had something like 1, 3, 9, 18, why would this be an example of something that is not geometric? Well, I'm multiplying by 3 in these first 2 steps, but then I'm multiplying by 2. So we do not have a consistent pattern. And therefore, this cannot be geometric. So we really have to check to make sure that the pattern is showing up as consistent. Okay, and so with that being said, let's come down here And let's go ahead and determine if the sequence is geometric or not. If it is geometric, we are going to write what the common ratio is, what I'm multiplying by to get that value. And if it is geometric, I'm going to use that pattern or what I'm multiplying by to get the next three terms. So I'll do this first example with you. It looks like I would have to multiply by 3 to go from 4 to 12. And then multiply by 3 again would get me 36. Times 3 again, times 3 again. This all works out. And so R, my common ratio, is 3. And if I multiply 324 times 3 again, I would get 972. And then if I multiply that by 3, I'd get 2,916. And if I multiply that by 3, I get 8,748. All right, I want you to pause the video, and then I want you to try the next two. All right, so if you took a moment to try these next two, you would see that in problem 2, I'm not multiplying by any number in order to get the next term. I also am not consistently adding numbers to get the next term. This would be neither geometric nor arithmetic. And so I would circle no and put a line through the common ratio in the next three terms. In this next one, it might be a little more difficult to tell with these decimals. So I might start over here. I might think to myself, okay, 15 times what gets me 30? Well, 15 times 2 gets me 30. Does that work here? So if I start at 7.5, would 7.5 times 2 get me 15? Yeah. So going at 3.75, if I type 3.75 times 2, do I get 7.5? Yeah. So sometimes it might be easier to work at numbers that make more sense to you and then see if the pattern fits the decimals or fractions. All right, so let's come back up here and talk about an equation to help find any number in the list, just like we had an equation for arithmetic sequences. And so just like with arithmetic, we're going to start with f of n equals, and we're going to have that a value. And when we talked about exponential functions, we talked about what the a value represents. And it will mean the same thing in this case as well. Times r. And when we talked about exponential functions, we use the letter b, but we're going to use r for common ratio, raised to the n exponent. So really the only difference here is the fact that I have f of n instead of y. F of n is the number in the list. Okay, we call this the value. We have n instead of x, and n is the position in the list. And we call this the term. And let's see. A still represents the initial value. And when we talked about exponential functions, the initial value was the y-intercept. And when we talked arithmetic, we said that that is the number in the zeroth, that is the zeroth term, or in the zeroth position. So that part doesn't change. Just like with arithmetic, I'm going to have to work backwards by 1 in order to get that a value. And then, of course, r is that common ratio, that number that I'm going to multiply by in order to produce my list. So let's put this into practice. We'll come back down here to some key ideas. And the first thing I'm going to say is remember that this is the first number in my list. And so this number 2 would be considered f of 1. If f of 1 equals 2, it's because the first number in the list is 2. And if f of 2 is 8, it's because 8 is the second number in the list. And if f of 3 is 32, it's because 32 is the third number in the list. And 128 would be f of 4. That's the fourth number in the list. Dot, dot, dot means an infinite. And so that would represent f of n, a number in the list in the nth position. Now, in this particular case, if I asked you to find the common ratio, it looks like I would be multiplying by 4 in order to go from one term to the next. And so my R value is 4. And so if I'm going to fill out this equation, which is f of n equals, I need an a value. I have my R value to the n. And in order to get this a value, I'm actually going to have to work backwards, right? So if I'm multiplying by 4 in this direction, what am I going to have to do in order to go to the left or backwards in order to get that 0th term? Well, I'm going to have to do the opposite of multiply, and I'm going to have to divide by 4. What that means is I take this number in the first position, and I'm going to divide it by that common ratio. And so 2 divided by 4 would give me half. And half ends up being then my a value. Okay? All right, well, how to find the common ratio? Sometimes it's not always easy to see what number you multiply by to go from one term to the next. In fact, kind of like problem number 3 here, it wasn't easy to tell how to go from 3.75 to 7.5. And so what you could do is you could take R equal to, you could take any value, any number in your list, and you can divide it by the previous value. So for example, if I wanted to find the common ratio of this problem number 3, I could take 7.5, so R equals 7.5, divide it by the previous value, which was 3.75. And if I type that in my calculator, I get 2. And that ended up being my common ratio and was a little easier to see once I got to the 15 and the 30. Okay, so when we give you geometric sequences, we are always going to give you consecutive numbers, meaning at least 2 numbers in the list that are right next to each other, so that we can use this model to find the common ratio. All right, so let's try a couple problems, or at least I can get you started on a couple problems, and then your job would be to finish the problems. All right, so let's take a look. For some people, it's easy to tell. This is for each geometric sequence. So I know that they're geometric. I don't have to make that determination. For some people, it's easy to see that 1 times 6 is 6 and 6 times 6 is 36. Or to find the common ratio, I could take any number, 216, divided by the number previous, 36, and I would get 6. So my common ratio is 6. What that means is that I can fill in my general equation as my a value. I have to find that, times 6 to the n. Okay, so my common ratio is that number in parentheses. Now, in order to find the a value, if I multiply by 6 going to the right of my list, and I need to find the number before the first term, I'm going to have to do the opposite and divide by 6. Okay, what that means is that I'm going to have to take 1 and divide by 6 in order to get the number in the 0th term. So I take the number in the first term, I divide it by that common ratio, because I'm going to move in this opposite direction here, and that's going to give me the a value. Okay, and then I can go ahead and use this equation to find f of 12. Remember, 12th number in the list. So this is find the 12th number in the list. And so I'm going to say 1/6 times 6 raised to the 12. And you can type this into your calculator. You can type this into Desmos. And you're actually going to get a really large number. You're going to get the number 362,797,056. Let's see if I can unzoom. There we go. And if I were to put 056, my apologies. If I were to put parentheses in there, I would have the number 362,797,056. Okay. Now, your job in 5 is to do something similar to problem 6. Your job in 6 and 7 is to, again, find the common ratio, use that to create an equation, and find a certain number in the list. Let me give you a little hint for something like 7. Again, I have these consecutive numbers. And so to find that common ratio, I would take the 25. I would divide by the previous value. And 25 divided by 100, I'm going to say as a fraction is 1/4. Or 0.25. So you're going to have to do some work to figure out the 0th term. You could say 1/4, or you could say 0.25 to the n, and then you're going to use that equation to find the 8th number in your list. All right, finally, let's take a look at something like 8 and 9. So we've talked a little bit about problems like this when it comes to arithmetic. At least in my class, we talked about some strategies. One of the strategies was potentially making a list of numbers. Some people made a table like they see in problem 9 to help them. But either way, you're going to use the information to figure out a general equation and then evaluate for that general equation. Okay, same idea here. You're given the 4th, 5th, and 6th numbers. So if you want to make a list, you can, or you can just go right from here to find what you need. And your job is to use your information in order to find the first term. All right, so you're going to do the best that you can to finish the back side of this page and be ready to ask questions tomorrow.